Welcome to this VMware ThinApp how-to video. In this video we will demonstrate how to enable and configure ThinApp's AppSync function within your ThinApp packages, and specifically show how to use AppSync functionality with ThinApp packages that have separate data container and entry point files, thus allowing you to update package suites such as Adobe Photoshop CS3, Microsoft Office, or your own custom suite of packaged apps. First, let's go over some of the bullet points with AppSync. It is designed to utilize an existing web server in your environment, such as an IIS, Apache, or Abyss web server, for updating remote systems, for example home user PCs, traveling user laptops, or USB sticks. While it can use HTTP or HTTPS connections, it can also be used on a local area network and utilize the file protocol versus those HTTP or HTTPS protocols needed by a web server. The general setup and usage procedures are to first create the original ThinApp project, embedding the URL to the web server or file share within it along with the frequency checks and message data. Once deployed, that ThinApp packaged app will check for updates on that web server or file share based upon those settings. When an updated project is built and placed on that web server or file share, the originally deployed ThinApp packaged app detects that upon next launch by doing an SHA-1 hash comparison on the entire primary data container. ThinApp then does an SHA-1 hash comparison on each block of data within that data container to determine which blocks have changed, thus allowing only the differences to be downloaded versus the entire new ThinApp packaged application. These differences are then compiled in the background with the original package by ThinApp to create the updated package for the remote end user. Some specific points of interest now come into play with multi-entry point ThinApp packages, for example when packaging Microsoft Office or an Adobe Photoshop suite of applications. If you're updating a ThinApp packaged app which has multiple entry points, the primary data container name as well as each entry point name must remain the same between the original and updated packages, and all of the entry points created for that ThinApp package suite must be placed on the AppSync server next to the primary data container file. Additionally, you will not be able to utilize AppSync to update the original ThinApp package to a completely different ThinApp packaged app, as the primary data container names must remain the same. As a reminder, the AppSync update process downloads the differential data versus the entire package, but in order for this to work, the original ThinApp project must be utilized and updated via a file or text modifications or by the use of the SB merge tool within ThinApp. This is because doing a completely new capture will create a completely new SHA-1 hash value versus just an updated SHA-1 hash value by the use of the SB merge process or file copy or modifications of the project directly. At this point, we will demonstrate that we are running on a clean VM by opening up Add Remove Programs. Within Add Remove Programs, you will see that I have VMware Tools installed and Windows Installer 3.1, which is part of the operating system. Next, I am opening up my AppSync demo folder. In here, I have pre-built packages of Java 142.18, 150.16, and 160.16, which I have pre-configured with AppSync parameters and built into packaged apps. Within the AppSync parameters under each package, I have enabled and configured the AppSync URL and AppSync updated message values for the purpose of this demonstration. The AppSync values points to a shared folder called WebSRVR on my local VM system. This folder will be used as my AppSync web server share folder for the purpose of this demonstration, and will contain the updated packaged applications I wish to deploy. To start this demonstration, I'm going to first simulate deploying my original application to my end systems by copying the Java 142.18 package to this VM's desktop. While the desktop is not a common location to store packaged applications, I am using the desktop in this demo to show what happens during the AppSync update process in the background. Next, I will take the newer Java 150.16 package and deploy it to my AppSync web server folder to simulate placing the updated package on my AppSync web server. Note that I also copy the endpoint executable as well, even though my AppSync URL value in my package INI is only pointing to the java.dat file. Now I will execute the originally deployed Java 142.18 application, where you will see that I am running Java 142.18 by the results of the Java tester website. You will also see the creation of the following files. The ASD file is the AppSync date timestamp file, which records when the last AppSync check was done on the original package, in this case the Java 142.18 package. The Java ASC file is the AppSync executable file for the primary data container. It contains the differential data between it and the original Java DAT file. The compilation of this differential file with the original Java DAT file will create the new primary data container. Note also the creation of the iExplorer with JRE150 ASC file. This is the updated endpoint for the new Java 150.16 package, and it will be used to replace the original iExplorer with JRE142.exe entry point file, since that entry point would not work with the new java.dat primary data container file. Again, note that I am running the original Java package, which is Java 142.18. I am now closing this Java package and am re-executing it, and here you will see ThinApp performed the update. The original java.dat file was renamed java.da$, and the new java.dat file was created by compiling java.da$ with java.ase. Additionally, you can see the iExplorer with JRE142.exe was deleted, and the newer iExplorer with JRE150.exe has replaced it. If we click OK, you now see a window appear stating the application was updated, and we need to relaunch the application using the new version of the endpoint. This is because the original iExplorer with JRE142.exe endpoint was no longer valid and thus replaced with the newer iExplorer with JRE150.exe endpoint executable. Upon relaunching the app with the new entry point, you will see the creation of a new Java 150 update 16.asd file, as the inventory name of this updated ThinApp package has changed. Additionally, the Java tester website shows us the application is indeed running with Java 150.16. I am now going to clean up the older java.da$ and ASD files to redemonstrate this process by upgrading the current Java application to Java 160.16. Next, I am copying the Java 160.16 packaged application to the web server folder to simulate the deployment of a newer packaged application. In the interest of file system cleanup, I am also deleting the iExplorer with JRE150.exe entry point file, as it is no longer needed. Next, I will launch the iExplorer with JRE150.exe entry point, and you will see the creation of the Java 150 update 16.asd file, the Java ASC file, and, if I loop this section of the video playback temporarily, an ASL file. The ASL file is the AppSync lock file and is created during each update process to ensure only one update occurs on the packaged application at any given point in time. It should be noted that while this file was not seen during the first update process, it was created. However, since the update took mere moments to complete, the Windows operating system did not have time to display this file, as it was immediately removed upon update completion. You will also notice with the iExplorer with JRE1616 ASC file, which is the replacement to the iExplorer with JRE150.exe entry point file. Additionally, the Java tester website reports we are running Java 150.16. Upon closing this application, you will see that nothing actually occurs until we launch the original entry point, at which point the iExplorer with JRE1616 replaces the older entry point, the older java.dat file is renamed to java.da$, and the newer java.dat file is created by compiling the Java ASC and java.da$ files. Clicking OK on the update messages and relaunching the iExplorer with JRE1616 executable launches the application and once again creates another ASD file, as this package is also configured to check for AppSync updates. Note the Java tester website shows that we are now running Java 160.16, which is the latest version of the ThinApp package we have deployed to our AppSync server. This concludes our ThinApp AppSync video. We thank you for watching and hope you enjoyed it.